Lesson: Case Studies and Applications. Artificial intelligence has become a pivotal force in the realm of cybersecurity, particularly in the domain of vulnerability management. The integration of AI in this domain is not merely theoretical, but is actively being applied in various practical scenarios to enhance the detection, assessment, and mitigation of vulnerabilities. This lesson delves into several case studies and applications that illustrate how AI is revolutionizing vulnerability management, providing a robust understanding of its significance and efficacy. AI-driven tools have significantly improved the efficiency of vulnerability management processes. Traditional methods often rely on manual efforts and static rule-based systems, which are not only time-consuming but also prone to errors. AI, on the other hand, leverages machine learning algorithms and pattern recognition techniques to automate the identification and prioritization of vulnerabilities. For instance, a study by IBM Security found that AI-powered systems can reduce the time to detect and respond to breaches by up to 27%. This reduction in response time is critical in minimizing the potential damage caused by security breaches. One notable case study is the implementation of AI by Microsoft in its Security and Compliance Center. Microsoft employs machine learning models to analyze vast amounts of security data, identifying patterns that indicate potential vulnerabilities. This proactive approach enables the company to address vulnerabilities before they can be exploited by malicious actors. According to Microsoft's internal reports, their AI-driven security measures have resulted in a 60% decrease in the number of successful cyber attacks on their systems. This demonstrates the tangible benefits of AI in enhancing the overall security posture of an organization. Another compelling example is the use of AI in the vulnerability management processes of the financial sector. Financial institutions are prime targets for cyber attacks due to the sensitive nature of the data they handle. AI-based systems are employed to continuously monitor network traffic, user behavior, and transaction patterns to detect anomalies that may indicate a security threat. A study conducted by the Financial Services Information Sharing and Analysis Center revealed that AI-enabled cybersecurity solutions have helped banks reduce the incidence of fraud by 30%. This underscores the efficacy of AI in safeguarding critical financial data and ensuring the integrity of financial transactions. The healthcare sector has also witnessed significant advancements in vulnerability management through the application of AI. Healthcare organizations face unique challenges due to the vast amount of personal and medical data they manage. AI technologies, such as natural language processing and predictive analytics, are used to identify vulnerabilities in medical devices and electronic health record systems. For example, the Mayo Clinic has implemented an AI-based system to monitor and secure its network of medical devices. This system has successfully identified and mitigated several vulnerabilities that could have compromised patient safety. The use of AI in this context highlights its potential to enhance the security of critical infrastructure in the healthcare industry. AI's role in vulnerability management is further exemplified by its application in the energy sector. Energy companies are increasingly adopting AI to protect their critical infrastructure from cyber threats. AI-driven systems are used to monitor and analyze data from sensors and control systems to detect signs of potential cyber attacks. A case study involving a major energy provider demonstrated that the implementation of AI-based security measures led to a 45% reduction in the number of successful cyber attacks on their infrastructure. This case illustrates the importance of AI in safeguarding essential services and preventing disruptions that could have far-reaching consequences. In addition to these sector-specific applications, AI is also being used to enhance the capabilities of vulnerability management platforms. These platforms leverage AI to automate the process of vulnerability scanning, assessment, and remediation. For instance, the AI-powered platform developed by Tenable, known as Tenable.io, uses machine learning algorithms to analyze vulnerability data and predict the likelihood of exploitation. This predictive capability allows organizations to prioritize vulnerabilities based on their potential impact, thereby optimizing their remediation efforts. According to Tenable's reports, organizations using Tenable.io have experienced a 40% improvement in their vulnerability management efficiency. This highlights the role of AI in streamlining vulnerability management processes and improving overall security outcomes. Moreover, AI's ability to process and analyze large volumes of data makes it an invaluable tool in threat intelligence. AI systems can aggregate and correlate data from multiple sources, providing a comprehensive view of the threat landscape. This enables organizations to identify emerging threats and vulnerabilities in real time, allowing for a more proactive approach to cybersecurity. A notable example is the use of AI by the cybersecurity firm CrowdStrike. Their AI-driven threat intelligence platform, Falcon, continuously analyzes data from over 1 trillion events per day to identify potential threats. This real-time analysis has enabled CrowdStrike to detect and mitigate threats with unprecedented speed and accuracy. The success of such platforms underscores the transformative impact of AI on threat intelligence and vulnerability management. While the benefits of AI in vulnerability management are evident, it is important to acknowledge the challenges and limitations associated with its implementation. One of the primary challenges is the potential for AI systems to generate false positives, which can lead to unnecessary remediation efforts and resource allocation. Ensuring the accuracy and reliability of AI-driven systems requires continuous training and validation of the underlying models. Additionally, the ethical considerations related to the use of AI in cybersecurity, such as data privacy and algorithmic bias, must be carefully addressed to maintain trust and accountability. Despite these challenges, the future of AI in vulnerability management appears promising. Advances in AI technologies, such as deep learning and reinforcement learning, hold the potential to further enhance the capabilities of vulnerability management systems. These technologies can enable more sophisticated threat detection and response mechanisms, ultimately leading to more robust and resilient cybersecurity infrastructures. In conclusion, AI has emerged as a game changer in the field of vulnerability management, offering significant improvements in the detection, assessment, and mitigation of vulnerabilities. Through various case studies and applications, it is evident that AI-driven systems can enhance the efficiency and effectiveness of vulnerability management processes across different sectors. The integration of AI in cybersecurity not only helps in proactively addressing potential threats, but also in minimizing the impact of successful attacks. As AI technologies continue to evolve, their role in vulnerability management is expected to become even more critical, paving the way for a more secure digital landscape.